Imagine this. You're flying at nearly twice the speed of sound. Then suddenly, you cut throttle, pitch up hard, and flip the jet 180 degrees. In midair. No stall, no crash, just controlled chaos. To the untrained eye, it looks like magic. But there's a secret behind these physics-defying moves. A hidden layer of technology that turns fighter jets into airborne acrobats. How can a 20-ton machine move like a gymnast at Mach speed? Let's break it down. We all know jets are fast. That's no surprise. But in aerial combat, speed alone doesn't win. What actually wins fights up there is maneuverability. The ability to outturn, outclimb, and outreact your opponent before they even know where you are. And achieving that kind of agility, especially at supersonic speeds, is not just about muscle. It's about finesse, balance, and technology working in perfect sync. Go back to World War II. Aircraft like the P-51 Mustang relied on lift, control surfaces, and brute strength to turn tight. But once jets broke the sound barrier, things changed. At supersonic speeds, airflow becomes unpredictable, and traditional elevators, ailerons, and rudders start to lose their effectiveness. Fighter jets needed a new toolkit. One that didn't just push air, but controlled it like a sculptor shaping clay. Enter thrust vectoring, a game changer. Instead of only pushing air backwards, jets like the F-22 and Su-35 can angle their engine nozzles, directing thrust up, down, or sideways. Think of it like steering a rocket in mid-flight. You're not just relying on wings anymore. The jet is literally pushing itself in different directions. At low speeds, where aerodynamic control weakens, thrust vectoring keeps these aircraft agile and deadly. Here's something surprising. Most modern fighter jets are intentionally unstable. They're built to be twitchy, on edge, almost impossible to fly manually. Why? Because instability means responsiveness. It lets the jet change direction instantly, instead of fighting to stay balanced. But here's the catch. No human pilot can manage that kind of instability on their own. That's where fly-by-wire comes in. Instead of direct mechanical linkages, modern jets use digital systems to interpret the pilot's commands. You're not moving flaps yourself. You're telling the computer what you want the jet to do. That computer, in turn, makes hundreds of adjustments per second, constantly tweaking control surfaces and engine output to keep the jet balanced and responsive. A flying experience that feels effortless, but only because the onboard systems are working overtime behind the scenes. Even the wings themselves have evolved. Fighter jets now use flaperons, canards, and leading-edge extensions to manipulate airflow with surgical precision. At extreme angles, these features create controlled vortices, swirling air that sticks to the wings and keeps lift high, even when logic says the plane should stall. In many ways, a modern wing doesn't just fly, it tricks the air into helping it. Put all these systems together, and you get super maneuverability, a class of motion that defies conventional flight physics. These jets can fly at near-zero speeds, rotate in place, and reverse direction in mid-air. They don't just fly through the air, they manipulate it, redirect it, and dominate it. In a real dogfight, this gives pilots the edge, slipping out of lock-ons, forcing overshoots, or flipping around to land a missile shot where the enemy least expects it. So what does the future look like? We're moving towards AI-assisted flight control, 360-degree thrust vectoring, and even morphing wings that change shape mid-flight. These next-gen jets won't just react to the pilot, they'll anticipate, adjusting their flight surfaces, power, and stability before a move is even made. It's not just about better pilots, it's about smarter machines. So what's the secret behind the jaw-dropping agility of modern fighter jets? It's not brute force. It's not just raw speed. It's a finely tuned marriage of instability, digital control, and directional thrust, all working invisibly to let a human command a machine that bends the laws of motion. Because in the skies, agility isn't a luxury, it's survival.